Okay, so now we're doing with substitution. So you did substitution before. We're just going to take what we did before and add a little more to it. So, when necessary, solve for at least one equation for one variable. So one of the equations has to either say y equals or x equals. It doesn't matter which one. Substitute the resulting expression from step 1 into the other equation to replace the variable. Solve the equation. So let's do that first. So this has already got y equals. So I'm going to take what y equals and I'm going to plug it in for y. So I have 3x minus, and then I'm replacing y with 4x plus 11. All I've done is replace it. In fact, I should probably highlight the fact that this is the only part that I replaced. Okay, it came straight from here. I replaced the y value with what y equals. So then I multiply it through. Remember, this is like having a -1 here. So negative 4x minus 11 equals -7. And then I'm going to solve the equation. So x equals -4. So I've done all of what it said up to 3. So 4 says that I'm going to substitute the value from step 3 into one of the original equations and solve. Well, I don't want to plug it. Oh, that's not true. I can plug it back into either equation. I don't care. I'm actually going to pick the second one. So I have 4. I'm going to replace the x with -4 plus 11. So I get y equals -16 plus 11, and I get y equals -5. Now, I need to write that as an ordered pair, so -4, -5. And that's what you do. And this is my answer. Okay, so next one. It's already solved for y. So I'm going to take what this equals right here and I'm going to plug it in for the y value. So I have 3x minus 2. I'm going to replace my y with 2x plus 2. So the only thing I changed on that, the absolute only thing I changed on that was replacing the y with what y equals. I didn't do anything else with that. So I have 3x minus 4x minus 4 equals -17. And then you solve. It's making all that tapping noise. I'm sorry, guys. I'm trying really hard for it to not make all the tapping noise. So x equals 13. So I'm going to take that and I'm going to plug it back into one of the original equations and I'm going to pick the second one. Could I have picked the other one? Of course. But this one is just easier to do because it's already solved for y. So y equals 26 plus 2. So I get y equals 28. So then I write this as an ordered pair of 13, 28. And that is my solution. Okay, now if I look at this one, you'll notice that it does not have anything that says x equals or y equals. That means that you have to actually do it yourself. So I look for when the x or the y has a coefficient of 1. And this one right here has a coefficient of 1. So I'm going to solve for that one. So I'm going to subtract 4y from both sides. And I'm going to get x equals -4y plus 18. And I'm going to take this and I'm going to replace the x value. So x parenthesis, negative 4y plus 18 minus 3y. Now make sure you don't forget the whole rest of the equation, because I have had people do that. Negative 20y minus, I don't know that off the top of my head. So 18 times 5, that's 40, 90. Minus 3y equals negative 25. So it's going to get me negative 23y minus 90 equals negative 25, and solve this. Let's see. 65 divide by negative 23, and y equals, I feel like I did something wrong. Did I do something wrong on here? Where's my calculator? Make sure I subtracted 4y. I plug that in. 5 times 18, got 90. Oh, I see it. It's right here. That should have been a plus 90. So then I would have subtracted 90. There we go. I knew something was wrong. So negative 115. Is that right? I think so. So 115 divided by 23. Oh yeah, much better answer. Much better answer. So y equals 5. So I'm going to take that amount and I'm going to plug it back into, I'm going to pick the second equation. X plus 4 times 5 equals 18. So x plus 20 equals 18. Subtract 20 from both sides. And x equals negative 2. So then I would write it as the point negative 2, 5. And that is my answer. Over here, again, need to do the same thing. I need to subtract 2y from both sides so that I get x equals negative 2y minus 13. I take this right here and I plug it in for this x right here. Let's see if I can do a better job of that this time around. Negative 2y minus 13 plus, oops, I wanted to change back to the other color, plus 3y. You've got to make sure you're putting the rest of that in there. Negative 10y minus, and I believe that's 65. Yes, but after my last thing, I want to make sure I'm doing a better job. So negative 7y minus 65 equals 5. Add 65 to both sides. Negative 7y equals 70. Divide by negative 7 and get y equals negative 10. Plug that back into the original equation. So x plus 2. Replace the y with negative 10 equals negative 13. X minus 20 equals negative 13. Add 20, and get x equals 7. So the point is 7, negative 10. And that is my answer. Okay, so now here, doing the same thing. Taking this and replacing the y value. So I've got 4x plus 2 Multiply that by negative 2x minus 4 equals negative 8. Oops, I was supposed to write that in negative, like so. So I multiply that through. 4x minus 8 equals negative 8. These cancel out. Negative 8 equals negative 8. So that means that I can plug in any number for x and it's going to equal y because they're the same line. So the answer to this is infinite solutions. And if you remember from our last section, that means it would be consistent and it would be dependent. Okay, next, let's look over at this one. Okay, so I'm going to take y and I'm going to plug it in for the y. So I have, not that color, negative x plus 2. I'm going to replace the y with 1/2 x plus 1 equals 2. So negative, oh, I meant to do that. I did it again. So negative x plus 2 equals 2. These cancel, so I get 2 equals 2. So this means it's infinite solutions. And again, it's consistent and dependent. Okay, awesome. Okay, tree preservation. A town ordinance defines an adult tree as having a diameter greater than 10 inches and a sapling as having a diameter less than 10 inches. The ordinance requires that on a new building project, 2 new trees are planted for each adult, each adult tree felled, and 6 new trees are planted for each sapling felled. Last year, there were 167 trees felled. Okay. And the community planted 742 replacement trees. Okay. So what are the 2 types of trees that we're having? We have an adult tree and we have a sapling. So we're going to let x equal an adult, I can't even spell, tree, and y equal a sapling. And I should actually be putting number of adult trees, number of. And those of you that are like, that's a hashtag. Well, really, it's a number symbol. Long before we had hashtags, we called them number symbols. Okay. So, what we know, where's my highlighter? What we know is there are 2 new trees planted for each adult tree, and there are 6 new trees for each sapling. So when we do this, let me go back to my pen. So 2 new trees for an adult plus 6 new for a sapling. How many total replacements were there? There were 742. Okay. Then the other part says that there were a total of 167 trees felled. So adults plus saplings. We don't know how many adults, we don't know how many saplings, but we know together it's 167. Now, when we do this, or I want to say solve this, you could either pick the x or the y. It doesn't matter. I'm just going to pick the x. It doesn't matter which one you plug it in for. So x is going to equal negative y plus 167. Why did I pick that? I don't know. So I'm going to plug that back into the first equation. So 2, and I'm going to replace x with negative y plus 167. Sorry, I don't know why all of a sudden the writing changed. And then we're going to add 6y equals 742. Okay. So now, I'm going to take this, I'm going to get negative 2y plus, and just so I don't get it wrong again, 334 plus 6y equals 742. Okay. So I'm going to combine like terms, and I'm going to get 4y plus 334 equals 742. Okay. Subtract 334 from both sides. And I'm going to get 4y, I don't know that, 742 minus 334, 408. Divide by 4, divide by 4. I get y equals 102. Now I'm going to take that. I'm going to plug it back. I'm going to actually plug it back into this equation. So I'm going to get x plus 102 equals 167. Subtract 102. X equals 65. Okay, so then you have to write something. So 65 adult trees were felled, and 102 saplings. Really? Were felled. Okay. Next. I actually don't know how to pronounce this. Kimani has 2 equal-sized large pitchers and 2 equal-sized small pitchers. All of the pitchers together hold 40 cups of water. Okay, the capacity of one large pitcher minus the capacity of one small pitcher is 12 cups. So we have let x equal the number of cups of the large pitchers. Y equals the number of cups of the small pitcher. Okay, so I have 2 equal-sized large pitchers, 2 equal-sized small pitchers, and they hold a total of 40 cups of water. Then the second one says the capacity of one large pitcher, okay, so one large pitcher is X minus the capacity of one small is 12 cups. Okay, so now let's solve. So I'm going to add y to both sides. I'm going to get x equals y plus. Now the reason I solve for y or solve for x instead of y on this one, because it had the negative sign in front. Okay, so I'm going to take this, I'm going to plug it in. Okay, so here we go. 2 times the quantity, y plus 12. I guess I should use a different color. Maybe I should use like green or something. There we go. and then plus 2y equals 40. So 2y plus 24 plus 2y equals 40. So 4y plus 24 equals 40. Subtract the 24 to the other side. Get 4y equals 16. Divide by 4. And that gives me 4 cups for the small pitcher. And plug that back in to x minus and replace the y with 4 equals 12. So I'm going to add 4 to both sides, and I get x equals 16. So the answer to that would be there are 16 cups in the large pitcher and 4 cups in the small pitcher.